Hello everyone. In this video lecture, we are going to discuss numerical integration part 2. In the previous lecture, we have seen that how to derive Newton-Cotes quadrature formula. So in this lecture, we will start from that end. So we start with the Newton-Cotes quadrature formula for degree n. Basically what this degree means, it is crucial to understand the meaning of this degree. Xi is equal to a plus I b minus a by n, which is equal to a plus I times h. Here n is a degree and h is nothing but b minus a by n. So this h is nothing but the length of the step size and n is nothing but a degree. One more thing, let me briefly tell you that this degree is nothing but connecting points. For example, if you consider 1 degree, that means you are considering only 2 points which will generate a straight line. If you are going with degree 2, that is n is equal to 2, you need to have at least 3 points, and those 3 points are going to get connected, and hence you will have a slight curve. Similarly, if you increase this number, this degree, you will get better and better accuracy. It will basically fit on the curve itself, right? So let me show you quickly this Newton-Cotes quadrature formula. You can see here in box 1, and so you can see here this is the Newton-Cotes quadrature formula. Okay, so we want to start with finding any integral. For example, I is equal to integration a to b fx dx. So here, what does this mean? We are given any integral to find out, and we have to develop various methods. So here, put n is equal to 1, for example. Then what do we get here? We are considering 2 points x0 and y0 and x1 y1 as a trapezium or trapezoidal line. We are going to connect it, and for these 2 points, if you want to construct a difference table, you can easily see that only first order terms will be there. The higher order differences would be 0, and hence what will be the picture here? I is equal to integration a to b fx dx, which is nothing but x0 to x1 plus x1 to x2 plus x2 to x3 and up to this one, xn minus 1 to xn. Okay, so these are n different integrals, and we want to add these all things to get the final answer. That means I is equal to integration a to b fx dx. Fine. You can see here that what will be the picture. If you see here, this xy plane, this is nothing but our curve y is equal to fx, and for this curve, for example, this is my abscissa x0, which is nothing but a. Then corresponding y0 is the height, and here this is the point which is x0 y0. Fine. Similarly, for this one, if you go with the next point x1, that is nothing but x0 plus h, then x1 will have corresponding point y1, and that y1 is nothing but this one. So y1 is the height and x1 y1 is the point. Next one is x2 to x3 or x1 to x2, and then x2 to x3. In the same way, if you go for higher number of strips till the end of this one, you will cover the whole area under this curve y is equal to fx. Okay, so this is nothing but a figure to understand these strips for workout of trapezoidal rule. Similarly, you can consider the same kind of strip for Simpson's rule and so on. Okay, now let's work out. So in equation star, we will substitute n is equal to 1. Let me show you equation star. This is the equation star, that is Newton-Cotes quadrature formula. Substitute n is equal to 1 here, and what you will get here, the first subinterval is x0 to x0 plus h. So for this subinterval, if you simplify, then higher order differences will be obviously 0. So you will get 1 into h into bracket y0 plus 1 half delta y0. Now delta y0 by definition is nothing but y1 minus y0. So simplify it and you will get h by 2 y0 plus y1. Okay, this was for strip number 1. If you go further, then for second strip, you will have the pair of 2 points x1 y1 and x2 y2. Hence, the second portion of the strip can be deduced by this integral. You can see here in equation number 2, x1 to x2. x2 is nothing but x1 plus h. x1 plus h is nothing but x0 plus 2h. So basically you are working with x0 plus h to x0 plus 2h. So if you simplify it, you will get h by 2 y1 plus y2. Continuing in this way till the last strip, what we will get, xn minus 1 to xn as our integral, and the value of that integral is h by 2 yn minus 1 plus yn. So these are basically n different equations. Finally, if you add up all these integrals, you will get this boxed expression, that is the required integrals value. Integration from a to b fx dx, which is nothing but h by 2. You can see here that only y0 and yn, they remain unique, they remain single, and remaining all the entries y1 up to yn minus 1, all are double entries. And you can see here, for example, consider equation 1 and equation 2. You can see here that y1 here is there and here also it is present. So in this way, y1, y2 up to yn minus 1, they all are doubled, and y0 and yn are single entries. So in this way you can remember as well this trapezoidal rule. So this boxed expression is known as trapezoidal rule. Fine. Okay, what about the next rule, that is Simpson's rule or Simpson's 1/3 rule? If you consider n is equal to 2 instead of n is equal to 1, that is nothing but a degree in Newton-Cotes quadrature formula, then you need to consider 3 points, x0 y1, x0 y0, x1 y1 and x2 y2. These 3 points if you join, then you will have a slight curve. That curve represents a degree 2, that is nothing but a polynomial of degree 2, and obviously it's nothing but a curve and not a straight line, hence you will have more refined results. So it will give better or more accurate results as compared to the previous one, that is trapezoidal rule. So here just see that how we can go further. So here we will derive the expression in the same fashion that we did earlier in Newton-Cotes quadrature formula, but here the step size is 2. So obviously you can see here that our starting point is a, but the next point, that is x0 plus 2h, that is x2. Okay, and for this integral, if you find the corresponding values, then it will generate equation number 1 #1. So h by 3 y0 plus 4y1 plus y2. This is the value of this integral when you go with n is equal to 2. In the same way, for the next half or the second strip, you can see here you will start with x2 and go up to x4, and that is nothing but h by 3 y2 plus 4y3 plus y4. And finally the n minus 2th step to xn. So that will be the last strip. So total you will have n by 2 parts of your whole interval, and that is nothing but the resultant value for this integral is h by 3 yn minus 2 plus 4 yn minus 1 plus yn. So these are n by 2 integrals. If you add these all integrals, then you will get this boxed expression where y0 and yn they are unique, but y1, y3 up to yn minus 1, all these odd suffix entries, they are multiple of 4, and all even entries y2, y4 up to yn minus 2, they are multiple of 2. So you can easily remember this formula, which is known as Simpson's 1/3 rule, right? In the same way, if you go for higher degree expressions like n is equal to 3, 4, 5, 6, then you can derive in the same way the other formula as well. I'm just showing you the table and the corresponding which represents the corresponding formula. So here, if you substitute n is equal to 3, it's called Simpson's 3/8 rule. 3h by 8 times this one, y0 plus yn, plus, now you can see here, y1 plus y2, the first two entries, the second and third entry, y1 and y2, and then y4, y5. You can see here, the y3 term is dropped here, and similarly, all the terms of, which are having the suffixes in multiples of 3, they are dropped from this expression, plus up to yn minus 1, and they are nothing but the double. So 2 times y3 plus y6 up to yn minus 3. In the same way, if you substitute n is equal to 4, you will get Boole's rule, which is expressed here, and n is equal to 6, that is nothing but Weddle's rule, which is also given here. So in this way, we can derive all these formulae. Your task is to understand the methodology, that how to derive such formulae. And one more thing, Simpson's 1/3 rule is mostly used in these all basic cases, but as you go for the higher order terms or higher order formulas like Simpson's 3/8 or Boole's or Weddle, then you will get much better results. So thank you very much. I'm sure that these understanding might be clear now in your mind, that how to understand such formula and how to work out. In next lecture, we will solve certain problems based upon these formulae in order to understand the gist of this formula very well. Thanks a lot.